Good morning to Warhill's fantastic chemistry students. Today, we're going to start learning about gas laws. I'm Mrs. Mooring, and let's get to it.
Okay, so we're going to look at an introduction to solving gas law problems. Our objectives today is to review what causes pressure. This is from watching ChemThink earlier. To recognize the units for pressure. To review the relationship of pressure, volume, and temperature. And we're going to learn how to convert Celsius to Kelvins using this equation here. And the reason that we are doing this is because this relationship right here is very, very important for solving gas laws. And this guy is called PVT man. Okay, so what I'm doing here is every time you hear PVT, I want you to begin to memorize this triangle here. All right, so for a good website etiquette here, I'm saying that I'm using a lot of images from OpenStax and also from ChemThink. Okay, so let's take a look at what you learned from ChemThink. So you learned that pressure is caused by particles colliding with container walls. Pressure increases as particles hit the walls more frequently and as particles hit the walls with more force. The units that we will use for pressure in our next lesson's activity are atmospheres, ATM, millimeters of mercury, mmHg, torr, that's the same thing as mmHg, and kilopascals. You should recognize all of these as units for pressure. If you need to, you can convert by easily found conversions. Don't worry, you do not need to memorize these. All right, let's take a look at this tutorial, and we're going to look at the relationship between pressure and volume. So I am going to start this little thing up and take a reading, and we can see that we have high volume, low pressure, and as we decrease the volume over here, we can see that the pressure increases. So we have an inverse relationship. You also investigated the interaction between pressure and temperature. So let me start this one up. At a low temperature, we have a low pressure, and as we increase the temperature, we can see that the pressure increases as the particles are hitting the walls with more frequency and with more force. If we graph this, we get a beautiful straight line, and it appears to go through the origin, but that only works if we use the correct temperature scale. And the correct temperature scale to use is one that is called Kelvin. This is new for you. So what we are going to do is we are going to convert degrees Celsius to kelvins. Anytime we solve gas law calculations, we have to convert any temperatures to kelvins. The Kelvin scale was set up so that when all particle motion stops, that is theoretical 0 Kelvin. Since there are no particles moving, there are no particles colliding with the container walls, so the pressure would be 0. Here is the equation that you will use to convert. 273 plus degrees Celsius is kelvins. Here's two thermometers, one showing Celsius, one showing Kelvin. And what I want you to notice is what's different here. It's just there's an offset of 273, just like it says. The difference between the boiling point of water and the freezing point of water is 100 degrees Celsius, and it's also 100 degrees Kelvin. All we've done is change the temperature scale by 273. Actually, 273.15 to be precise, but we'll be okay with 273. So let's take a look at what you learned last week. Remember that 1 mole of gas equals 22.4 liters at STP. And today we learned that 1 atmosphere is the same thing as 760 millimeters of mercury, or 101 kPa. And we learned that T we can call either 0 degrees Celsius or 273. So in red here is standard temperature and pressure, and these are different ways of expressing it. We're just converting between one unit and another. So what I want you to do is convert the following Celsius temperatures to Kelvins. So pause and solve the conversions. All right, hopefully you're ready for the answers. Did you get it right? Okay, so that's it for the content for today. So what you should have learned is, or reviewed, is what causes pressure, to recognize the units for pressure, to review the relationship of pressure, volume, and temperature, and to convert Celsius to Kelvins using 273 plus 0 degrees is equal to Kelvin. So, once again, this is PVT Man! And in our next lesson, what you're going to learn is to use P1V1 over T1 equals P2V2 over T2. Notice the little triangle there? Except we're going to start even easier than that. We're going to break it into 3 pieces. First, you'll learn that P1V1 equals P2V2 and how to plug things in. And then you'll take V1 over T1 is V2 over T2. And then you'll take P1 over T1 equals P2 over T2. And you'll learn how to do all those calculations. Always, always Kelvinate temperature. Until next time, you all have a good day.